Hello, this is Cadillac1. Today I'm going to show you Weapon Essentials in Unreal Engine 4 C++. We're going to be discussing what a trace or an instant hit, if you're familiar with Unreal Engine 3, and how use structs work and enums work, and using enums as bullet types and structs for particular weapon properties. So sit back and let's begin. Alright, the first thing we're going to need to do is create our project. We're going to use the code third person template, and we're going to name it Weapon Essentials. And let's create the project. I'm going to pause it for a second and wait for it to build. Alright, it just got done building. So let's take a look, make sure everything's there. Yep. And also in the new 4.4 they changed everything from public and private folders now, which is pretty nice. So let's go ahead and do the local Windows debugger and let's get started. Alright, everything just got started, so let's go ahead and do a few things here real quick. Number one, let's go ahead and go to our character and open up the hero TPP. What we're going to do here, we're going to actually make a hand socket for the actual weapon to be held into. So I'm going to go into the hand_R and I'm going to add a new socket. We'll name it Weapon Socket. We'll save that. Exit. Alright, now let's go ahead and add a new coded project. We're going to make it from an actor, and we will name it Weapon. Create the class, and hit no. We'll go to our Weapon Essentials, and we're going to hit reload all and stop the debugging. Alright, so let's open up our weapon.h, weapon.cpp, and the first thing in our header, we're going to be adding a few things. We're going to be making the struct. It's called a use struct is what they call it. So this is how a struct is made. So it's a use struct, and that's how you declare a structure, which a structure, in case you did not know, in C++ a structure can hold a few items in particular, not items, but a few variables or objects in particular. For example, if you want to access a max ammo or current ammo or shot cost, weapon range and spread and stuff like that, we can make a struct for that for each weapon. So what we could do in the editor, we could actually go into the default properties inside the actual blueprint we're going to make, and we can actually literally change the numbers that way. But in a way, it makes it a more of an artistic, friendly way of doing things, and it really does help. So here's how we're going to do this. So we put the use struct there on particular in order for the engine to know that we're making a struct here. The next thing we're going to need is this thing called generated usestruct body. Reason for this, it's just kind of a common thing we have to have in the struct to make it work in the engine. So another thing is we're going to make a few U properties. We're going to need quite a bit of them. So U property. We're going to make a max ammo particular. Let's say edit defaults only category equals ammo. Then we're going to make this U property be an int32, and it's going to be max ammo. Well, it's indenting this for me already. Oh, I know why. We forgot to name our struct. We should probably do that. So we're going to have it be struct. I'm going to name it F weapon data. There we go. That is very important. Next thing we're going to do, we're going to know the U property, but I'm going to copy this real quick. I'm going to paste it down here. But I'm going to make it a category B config. More of like a configuration, like, hey, this is what's going to be, this is what's not going to be. So we're going to make another one called float time between shots. Now the reason for this is because, for example, you have a shotgun and it fires, you have to pump it. If you're going to have no time between shots, it's going to, every time you hit the fire mechanism, it's going to keep going plop, 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 plop. It's not going to go boom, shit, shit, boom, shit, shit when you actually do your firing. That's why we had the time between shots. Also for like handguns, so it doesn't like pop, 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 it doesn't make it ridiculous. It makes it more realistic. For the next U property will be an ammo property. We're going to be making a int32 shot cost. For example, like if you have a weapon that shoots like 3 shots at one time, like a 3-hit, you can make the shot cost do that. Basically, like the Mag 60 in Turok 2, like it requires 3 shots. So that's why the shot cost is pretty handy when you have particular weapons. And the next thing here, we're going to have a interesting one, which would be very handy for shotgun use and for sniper rifle use in particular. So we can say float weapon range, because every weapon has a particular range. We don't want to have a shotgun go like 5 miles down the road, because there's no way it can really do that. It's going to drop or eventually fall off eventually. So next thing we're going to do, another U property, make it be a config, and this will be a float weapon spread. There we go. And why this is handy is because if you have a shotgun, it's not going to shoot 8 bullets in the same exact spot. Or if you have an automatic, it's not going to shoot in the exact same spot when you hold down the trigger. Which is why the weapon spread is important, because it gives it a more realistic look to it when you shoot, and also gives you more realistic area when you actually shoot out the direction from the barrel. Alright, let's see here. I think that's all we need for our struct. And don't forget the semicolon at the bottom, that is very important. And the next thing we're going to need to do, we're going to be making a enum quick. And this enum in particular is going to be holding the bullet types. So then we can actually access them in our blueprint, and actually from a drop menu, we're going to make a drop menu that actually we can tell it, like, hey, is it a bullet, or is it a spread weapon like a shotgun, or is it going to have a projectile? So let's go ahead. This is how you declare enums in the Unreal Engine 4. Go u enum, and for it to actually be able to see the blueprint, like a drop menu blueprint, we're going to say blueprint type. Oh, God, I forget. I can't do that. So now we're going to name the namespace. We'll name it eWeapon Projectile. And then now we're going to make our enum and call it projectile type. The reason why I made a namespace for it is because, for example, if I have like a particular namespace, like if it's all weapon, I could say make it enum projectile, enum color, and stuff like that. It comes in handy when you want to do that. So the first thing we're going to do, we're going to put a suffix of e on each one, because it helps decipher if it's an enum or not. So we're going to say e-bullet for the first one. And the u-meta is there so we can actually make a display name so it doesn't show up as e-bullet, in case you want, if there's like an enum that has like a weird name to it. And for the artists on the other side, they're going to be like, oh, what the heck is this? So the display name really does help. So display name equals bullet. That really does help. I'm going to do the same thing for the spread. Make e-spread, e-meta, display name. Now you can't use semicolons, you gotta use commas, because it's an enum. And lastly, e-projectile. U-meta, display name, equals projectile. And there we go. Now our enum's complete, that's all we need. Now next thing we need to do, we're going to make a few things in our class, of course. So first thing we're going to do, we're going to make a U function. And this one in particular is a common one, void fire. This is what's going to be triggering our fire in our actual class for it to actually fire the weapon. But our fire class ain't going to be actually spawning the instant hit. What we're going to need is an actual thing it's going to transfer through. In the fire function, you're going to say, hey, if it's a bullet, you're going to go into fire once. If it's a shotgun, we're going to do a for loop for how much the weapon spread is, and it'll do it all at once for how big the number of the weapon spread is. And if it's a projectile, it's going to go to a different function for a projectile fire. But the projectile fire we'll do in another lesson, but we're going to do the instant hit ones first. So let's go ahead and make another U function. And it's going to be called void instant fire. There we go. Alright. Now, in order for us to access the struct and the enum, we have to make them objects. So let's say uProperty, say edit defaults only, because we want to be able to change the numbers and everything in it. That's why we use edit defaults only. If it's visible anywhere or read only, we can't access or change the numbers. But the only way we'd be able to do that is through C++ in general. And we're going to category equals config. So we'll all have it all in one subfolder. Makes it easier. And we're going to call this fWeapon data. We're going to get that. I'm going to call it weapon config. Semicolon. There we go. All right, now let's go get our enum. Enums have a different kind of way of doing things. We're going to say edit defaults only. We want this to be blueprint read and write. I can spell blueprint. Read and write. Because we want to be able to change it as a drop node if you want to make it be a bullet or a spread or a projectile. Make this category equal projectile. Actually, I'll make it config, because it's kind of a config property we want. So we're going to say, this is a way how we actually get the enums out. Say t enum as byte. And we're going to grab which enum, which will be the e weapon projectile, scope, and projectile type. And we're going to name this object projectile type. Easy as that. Alright, now for our actual default properties for things to work, we want to have a collision and we want to have a weapon mesh. So we're going to say this in particular, say uProperty. We're going to say visible anywhere. We're going to make it blueprint read only. Category equals collision. We're going to name this collision. We're going to have it be a t subobject pointer. We're going to make it be u box collision box component, and it's going to be a collision comp. And we're going to be naming it. All right. Now the next thing, we're going to need the actual mesh. So uProperty. I'm just going to grab this here quick, so I don't have to worry about writing back and forth. I'm just going to name this weapon. I'm going to name this mesh. Actually, put in this in config as well. Put it all in config. And then we're going to do t subobject pointer. Be use skeletal mesh component. The reason why I'm using skeletal mesh component is because I just want to use a skeletal mesh component. You can actually use a static mesh. You can actually, because the way we're doing this is because we can make a socket in the static mesh or in the skeletal mesh. It doesn't matter either way. I like to use a skeletal mesh because if I wanted to use animations, or if I have a bone dedicated for the actual muzzle, or if I want to put a particle to appear from the actual like slide, like from the weapon ejects out, I can make a projectile smoke appear if I wanted to. That's why I want to use a skeletal mesh component. And we're going to name this weapon mesh. Alright, so we get our common functions here and our common properties. So next thing we need to do, we need to go into our CPP file. We're going to get our common things in the constructor. So we're going to do collision comp equals PCIP dot create default subobject. And it's going to be, of course, the ubox component. And it's got these parameters, be this and text. We can name it collision comp. And we're going to make the collision comp equal the root component. Which the root component is the main component that everything is being parented to. Then we're going to get the weapon mesh. Matter of fact, I'm going to grab this. Weapon mesh equals, make it be use skeletal mesh component. Make it named weapon mesh. Okay, so we're going to make weapon mesh attached to the root component, which is the collision component. We're going to get the member access. I should say attached to, which would be to the root component. All right, now let's go ahead and declare these functions here, our void fire and our instant fire. And let's say void a weapon fire. And then we'll need our next function, void a weapon instant fire. And there we go. All right, so let's go ahead and build this, make sure everything's working. All right, we're all good to go. Everything's working. So, all right, in our next lesson here, I'm going to, not next lesson, but the next part of our lesson here, I'm going to discuss a little more information about what trace will do and how we're going to make this work. All right, so back to our weapons.cpp. We're going to do a few things. In order for us to know what kind of projectile or instant hit trace we're going to be making, we're going to have to say this. Let's say if projectile type, which is our name of our enum we made as an object. We're saying if it equals eWeapon projectile, which is the name of the namespace. In order to access namespace, you have to use a scope, which is these two colons here. We're saying if it equals bullet, which of course is right here in our enum projectile, eWeapon projectile, if that equals bullet, because we already got the projectile type right here of what we're calling from it. We're asking it if it equals bullet, spread, or projectile. If it equals one of those, do something. And of course, I'm going to actually in the new Unreal 4.4, we have to use this because they got rid of all the globals, so it's the engine.h. Or else we won't be able to use in a particular pointer called gEngine. So we can actually make our add on-screen debug messages. On-screen debug message. So we're going to make sure it actually works. We're going to say -1, 2.f, and make it, what color we'll make it? We'll make it black. And we'll have it say text bullet. Simple as that. And of course, we want to call, because it's an instant fire for just a bullet, we want to call the instant fire function. Now, this is where it gets a little bit interesting. So we're going to say if projectile type equals eWeapon, if I can hit E, weapon projectile. If it equals a spread, we have to do these particular things. Because this is how I usually do the shotgun kind of spread. I usually do, I want to make sure, let's say gEngine, make sure we actually have it saying if it's a spread or not. It's just a simple check to make sure everything's working. Let's say spread. So then what I do a for loop. And I'll do int 32 and make it I equals 0. And then I is less than or equal to, if you remember our struct here, we have a weapon spread. The weapon spread will tell us how much it's going to be spreading at all. Because we get to tell like a pistol we don't want to spread at all, but if we want to have some spread, we can. But for a shotgun, I would say a weapon spread. If it's less than or equal to weapon config, which is the name of the struct. If I can find it. Yep. Oh, right. Where is it? There we are. The name of the struct object we made. Weapon config. And we use the dot operator to access everything because we did not make it a pointer. It's better to use a struct as a dot operator. Unless we're actually directly accessing the struct from a different way. So we're going to try to find the weapon spread. And then I'm going to say I++, so the for loop can continue on until it reaches the maximum amount of the weapon spread. And then we say instant fire. And there we go. And the reason for this, why I do it as a for loop instead of just having it call instant fire every time, is because the instant fire is going to have a random seed in it, so it's going to have a random direction for every time you call the function. Because if you just call instant fire every time, it's just going to give us a random number every time. So now we're going to do the next one. If projectile I'm going to grab this, as a matter of fact. I'm going to make it if it equals projectile. It's going to do something else. But I'm going to in a newer lesson, I will show you guys how to make a different projectile class to spawn from and know where to actually spawn it to and make it actually happen. Projectile. Alright, so now there's a few things we need to do here first. Number one, we're going to need a couple of protected functions because it's nice to have. So we're going to make protected. If you don't remember from my inheritance video, the protected functions mean it can only be accessible if this class is inherited by it. So we need a void. We need a fHit result. We need this return type. And it's going to be called weapon trace. And we're going to make a constant vector, f vector. That could be a trace from, and a constant f vector reference to trace to. The reason being we need this, I'm going to make this completely constant as well, is because we want to get the way a trace works. It needs where it came from and where it ended. That's how a trace works. So a line has 2 points. Obviously with a weapon trace, it needs a line that has to have 2 points. Know where to draw the line. And the next thing we need to do, we need to make a void, another function called void process hit, instant hit. And what this will do, it'll basically tell us like what hit it, and if it did hit something, do something. Basically what it does. Constant. We're gonna make a first parameter be a hit result, and we're going to have a reference to impact. And constant f vector, I'm going to make it named origin, and a constant f vector, make it named shoot direction, and we're going to make a int 32 for our random seed, for our random directions for where it's going to shoot, and I'm going to make a float for the reticle spread, which I will teach in a later on tutorial here later on in the future. But this will be there handy dandy for later lessons that we could reference from. Alright, so let's go ahead and declare these down here. I'm going to say fHit result. I'm going to call it weapon trace, of course, a weapon trace. We'll need the constant. Where are we at here? F vector trace from, and the constant F vector reference to trace to, and it needs to be a constant at all times. Alright, so I'll grab our last function here. Actually, I'm going to literally click and drag it so I don't type it all out. We cannot forget the class where it's coming from. Alright, so with our weapon trace, we are going to have to do these particular things to make it work. We are going to need, actually, let's start with our instant fire first, just in case. So for the instant fire to work, we are going to need a bunch of local variables we're going to make ourselves. So we're going to have, most of these are going to be constant because we don't want them to change at all because they're going to be coming from a particular socket from the weapon. Which in case of that being said, let's see here quick. I'm going to, we'll just go ahead and continue on. So we've got constant int 32 called random seed. And basically we're going to need a random seed, of course. We're going to need it for the random locations, of course. We're going to make it equal fmath, which is basically a math class that has a bunch of particular things we could do, particular functions like absolute value, cosine, sine, tangent, lerps, a bunch of stuff we could do with this. But we're needing in particular this rand, because it's going to give us a random number no matter what. So we're going to get the f. In order for us to have random C to work, we need an actual random stream generator. So we need an f random stream, which is also built in Unreal. We're going to name it weapon random stream. And we're going to put inside the parameter random stream, random seed. My bad. And then the next thing we're going to need is a constant float current spread. We'll make that equal weapon config dot weapon spread, obviously. And then the next thing is going to be a constant spread cone. Now this requires a little bit of math to kind of understand how this works. It's a thing called degrees to radian. Degrees to radians, there we are. Basically what it needs inside it is what we're going to be doing here, we're going to get half of the radian, half of the circle to kind of go in a, how would you say, if I could show you my hands, kind of like a inward acute angle shape to it, so we know it's going in the right direction. So it's like weapon config dot weapon spread times 0.5. Basically why we have to times 0.5, because we're getting half of that radian, kind of making a sort of like an acute angle to it. So it only goes out one direction, not the whole circle. So we actually shoot in a forward direction, so it doesn't go like flying everywhere. Unless you had like an explosion look to it, like a grenade, that would be a handy little thing to use for if you want like traces to appear, like a fragmentation to hit something. So the next thing we're going to do is constant f vector. We're going to need the aim direction. We're going to do aim dir and name it equals, actually as a matter of fact, let's see here, we're going to actually do weapon mesh. And I'll show you here in a little bit, but we're going to name our socket name MF. I'll show you what we're going to be doing, how we're going to get the rotation and the location of it. So I'm going to do get socket rotation. But I know it's an F vector, but there's a way you have to get the rotation and the vector from it. So I'm going to name it MF dot vector. Because the reason being we do this is because if your aim direction is not working so well, so getting like kind of like random variables coming out of it, like shooting not where it's supposed to be, and you want to get the rotation of that area where it's actually kind of rotated, you actually get that vector, that constant vector that won't move. So next thing we're going to need is a start trace, so f vector start trace. That'll equal, of course, the weapon mesh. We're going to get the actual location, get socket location, which would be MF. And the next thing, we're going to need the shoot direction, constant f vector shoot direction equals, this is where the shoot direction helps us with clamping the cone for where it's going to be shooting around, which is why we got to half the radian, which this little thing here for the random stream will be very handy. So we got the weapon random stream dot v rand cone. So what this needs is a few things. It needs three things in particular. We're going to get the horizontal half of the cone and the vertical half of the cone. So we get the exact coordinates of how big of the spread we need. So we need the aim direction for the actual direction where it's going to be shooting and coming from. Now the float direction, we just use spread cone because it recalculated where the vertical and the horizontal is with the currents, not the currents, but the spread cone. We recalculated this so we could get the horizontal and vertical with these parameters. Spread cone. It's pretty neat. I must say it was very clever. And constant f vector, we're going to need the end trace, of course, because you know where it ended. So this is a little bit different. So how we're going to do this, you're going to need a start trace and plus shoot direction times weapon config dot weapon range, type config. There. Basically what this is going to do is going to calculate the distance between the start direction and the weapon range. That's where it's going to keep going and going until you actually hit something, which will come in here. That's when we'll know when we actually hit something. Now since we got all this, we need one last thing, which would be the hit result. constant f hit result, and we're going to call it impact. It's going to equal the weapon trace, which is the function right below us, and we're going to actually dump in for the first parameter is his start trace, and the next parameter, of course, need trace 2, which should be the end trace. Simple as that. And now we can actually got all these things set up. We can do the process instant hit. And we're going to get impact. For the first one, we need the hit result, which is right here, the impact. Next thing, we need the origin. Where did it come from? Start trace, which is where the start trace, which is the origin. And then the next thing we're going to need the shoot direction, which we have shooter. And the next thing we're going to need that random seed, so we know which random direction is going to be shooting from. And then reticle spread, we're going to use current spread. And there we go. Alright, so now we're going to move on to weapon trace. Weapon trace, we're going to need to get a collision query parameter, which is kind of like the a way of saying what kind of parameters does it need to make the trace happen. Like, does it need to know, is it going to be inside the scene? Is it going to return a material? Is it going to ignore a particular actor when it shoots out? That's why we have the collision query parameters for the trace to work. So we're going to make but first of all, it needs a particular name, so I usually make a static f name. We'll call the object weapon fire tag. And we equal f name, and we'll make a text. We're going to call it weapon trace. Simple as that. And then we're going to do a f collision query params right there. We're going to name it trace params. This actually has the params actually have arguments inside it. Matter of fact, 3 of them, which will be weapon fire tag, which is the f name, and then you can see it in here. Requires a little more arguments, and this in trace complex. Yes, we want that true. And the last thing we need the constant actor, which would be the instigator, which is who is firing the trace, which would be the character. And now we can actually, since we actually got this in the object, we can actually say a few things inside the parameters. Like, for example, do we want the trace to be synced with the scene? Yes, we want to do that. And do we want it to have return of a physical material? Yes, we want it to return a physical material. And also we could also add, which is very handy, which is add ignore actor, which will be this. We don't want to have this be interfered with it. Now this is very important to have too, the f hit result object we're going to make here. Call it hit. Because this is actually important to force in it. Basically what that does, it's going to keep reinitializing it every time the weapon trace is called. Meaning it's going to be a new line, and if you don't have that reinitialized, it's going to be at the same line every time at the exact same spot you've had it before when you first fired it. That's why it's important to call that to make it forcibly reinitialize it. So now to actually draw the line, we do get world, and do line trace single. And it requires 5 parameters. We need the hit result, of course, we just made, which is hit. And we make the trace from, which we're going to be dumping in from the weapon trace here on instant fire. We're dumping this information here, that information to the first parameter. And then the next parameter, we're going to need the end of it, which is up here, which is end trace. But we're going to need to trace 2. Because we already dumped it from here and then there. We don't have to go back over here and get it because number one, they're local. We can't access them because they're inside the function. Next thing we need is the collision query params. As a matter of fact, I got a better idea because it needs a particular trace channel. We don't want to use the common trace channel. We want to use our own trace channel. Reason why? Because things get smoother and things act and behave better. So in order to do this, we have to do a few things. One little thing, and it's defining a game trace channel. in our header file. So what we do is define trace weapon. This is just the name I made. It's nothing particular. It's just I named it trace weapon. The ECC underscore game trace channel. We're gonna make it channel 1. This is an empty game trace channel. There should be, I think, 11 or 15 of them. There's a bunch of empty ones, which the game trace channel 1 is an empty channel. And I want an empty channel to have our own custom collision parameter inside it. So since we did that, we could actually say trace weapon as one of our channels. And next thing, it's going to need the collision query param, which of course is our trace params. I know it's quite a doozy, but it'll still definitely work. Once you get this all together, it will definitely make sense. And then also, of course, because it is a return type of hit result, we want to return hit. And that should work just fine. Alright, let's take a look here. So next thing we need to do our process instant hit. Honestly, this is a really quick one. This is a very short function. But you can make it really, but the thing is, when we do process instant hit later on in our new lessons, we're going to make this a little bit more in depth of how process instant hit is going to work and why we need it. So we're going to make a few local variables, just a couple of them. We need a constant f vector and trace. We'll make that equal to origin plus shoot direction times weapon config dot weapon range. This just helps to ensure it updates it just in case it didn't do it before. Now the next thing is going to be a new kind of a thing I want to explain that I didn't explain in my previous inheritance lesson I wish to explain now, which is this. I'll show you. Impact. Well, I'll show you when I get done typing. Get actor. Impact dot impact point, and then we're going to get end trace. Okay, so I get a lot of questions about this too, about what this particular statement says. Basically, we're making a conditional operator. That's basically what these two things mean, the question mark and the colon. Our condition is if it gets an actor. If we do get an actor, we want to make an impact point. But if we don't, we want to continue with our end trace statement. Meaning, I need to change that to a plus, not a equal. There we go. That was going to drive me nuts. So basically what it's saying, if we hit an actor, if we do, we want to make a point. We want to make it actually end the point there. If we don't, we continue on with the end trace for how long the weapon range lets us. Now the last thing we got to do, we're just going to draw our debug line. Just to make sure it works. We're going to make the in world, of course, be this get world, just to get the line. And then we're going to get the line start, of course, which is origin, and the end line, which of course is the impact dot trace end. That's how we get our for the impact for our hit result. We can actually get the impact of where the trace has ended. And the color we're going to make it black. And we're going to make the percent lines be true. Our lifetime will make it 1,000. That's 10,000, but that's okay. And we'll make the depth be about 10 units. Alright, so that should all be taken care of. Let's go ahead and build it, see what we got. Make sure it all compiles, make sure you have no errors. Be planning on making a lot more Weapon Essentials tutorials, and I really want to help everybody out here in this community, especially considering that, you know, weapons and instant hit tracing is a little bit more complicated. Alright, so that build was successful.